Mars, the red planet. Rockets have reached its bone-dry surface, but not people. The space between Earth and Mars is a hostile place to travel. Even specks of meteor dust could smash a spaceship apart. Getting there will require untested human courage and the best minds in science. But sometime early in the next century, we could send astronauts to our neighboring planet.
Mission Control, Explorer 1 has landed.
The journey is 250 million miles. It would last 2.5 years, including 18 months on the Martian surface. The greatest adventure since mankind landed on the moon. This time, the destination is Mars. Only a third the size of Earth, its volcanoes are as wide as the state of Missouri, and its tallest mountain soars 3 times higher than Everest. Some river valleys are as wide as the Grand Canyon is long. Gravity here is less than half of what it is on Earth. Days are only a few minutes longer, but a year is twice as long. And it's so cold that all its water is locked up in the polar ice caps or frozen beneath the surface.
We have a go for engine start. 6.
For most of us, a mission to Mars might seem like science fiction, but in fact, we're almost ready to take off.
I believe in the very early part of the 21st century, people will set foot on Mars.
Every piece of technology that's needed to do this mission basically exists today.
Mars is a place that we can go and live, and that makes it completely different than any other planet in our solar system.
We will have youngsters. We have second-generation Martians who will say, hey, my grandmother and grandfather back in the umpteenth century came from Earth.
The technology exists to go to Mars. Since the days of Apollo, a dedicated few have kept the dream alive by developing ingenious ways of surviving in space. But success hinges on a few stunning breakthroughs. New technologies would reduce the cost of the mission by 90% and cut travel time in half. And the countdown has started. Sometime early in the 21st century, the first manned mission to Mars could be ready. Their goal, to look for proof of life on Mars. They'll also search for valuable minerals and test the feasibility of human settlement. The trip would be timed to start as the Earth was about to swing past the red planet, which occurs once every 26 months. With a tug from Martian gravity, they would use less fuel and get there in just 6 months. One design on the drawing boards is for a Mars spacecraft at 27 feet in diameter, divided into 2 decks. The upper deck contains the crew's quarters, which would also double as their habitat on Mars. Worldwide interest in Mars has never been greater since NASA held a press conference to announce the discovery of this small meteor. Knocked off the surface of Mars many millions of years ago, it crashed into the Earth by chance. Inside, scientists found minerals that could only have formed in water. Along with the minerals were other structures that could have been produced by bacteria-like creatures.
The simplest explanation to us is that they are the remains of Martian life.
The meteor, and another discovered by British scientists, were tantalizing clues we might not be alone in the universe. But not everyone agreed with the evidence. Is there really life on Mars? It's an age-old question that's puzzled scientists for centuries and triggered an ongoing debate about manned or unmanned missions.
There's a thought that maybe we ought to send people to try and understand the history of life on Mars. The issue is we send robots to do a broad reconnaissance of the planet to isolate those places where humans might go. And after we send robots on the surface, we want to bring back samples with robots to get even more evidence. And then, if the evidence is overwhelming, then we go and we send people.
Yeah, Dan's about
Carol Stoker of NASA's Ames Research Center has spent the better part of her career trying to make Mars exploration practical using mobile rovers. By the year 2006, as many as half a dozen different-sized rovers are scheduled to land on Mars and send back surface information. One of the most capable is the Russian Marsokhod, which can travel hundreds of miles. But controlling rovers long distance is difficult. Images or commands can take 20 minutes to travel just one way. To beat the time delay, Carol Stoker designed a virtual reality system for driving rovers without waiting for confirmation and gathering information needed to choose landing sites for a human mission. But it's doubtful remote-controlled rovers alone will answer our big questions about Mars.
Detailed interaction with the surface will always be very difficult to control from Earth and very difficult to automate. So, for example, suppose that you had found what you thought was evidence of life on Mars. Suppose you'd found the fossil.
Even with instant TV images and real-time control, the so-called teleoperation system an astronaut might use from a base on Mars, just getting a look at an interesting rock is still complicated. To get the camera into position takes many separate commands. After each command, the driver must wait to see where the arm is, then decide where to move next. Add a 20-minute delay, and taking a rock sample with a geologist's hammer would be excruciating.
Might take a month or even a year to do the same task from the Earth you could do in an hour if you were there, live, or if you were even there in teleoperation mode.
Shuttle astronaut and Mars enthusiast Tom Jones shares Stoker's opinion.
We can only answer questions about the origins of life on Mars by going there and exploring in detail. It might take microscopes and toothpicks to find the answer in Martian fossils. It might require digging below the surface. And all of those tasks can't be addressed by landing simple robots on the surface. It's going to take human explorers in their laboratories and a long-term presence there to establish those answers.
Nobody is more passionate about sending humans to Mars than this group of scientists who call themselves the Mars Underground. Ever since 1981, they've been holding conferences to show skeptics how such a mission could be done.
These guys fly out to Mars. They fly out in convoy with another Earth return vehicle, which is their backup, but which, if they don't need it, can be used to open up a second site. The second site.
Bob Zubrin, one of the Mars Underground's most outspoken members, is full of ideas on how to cut the cost of sending people to Mars.
The most important person on the mission is the mechanic, the person who can fix the spacecraft systems, okay? Because that is what everybody's lives and the success of the mission depend upon. The other discipline that is important to the mission is that of field scientists, because that's what the mission is about. Therefore, What I say is 2 of each. If you had a 5th member and he's a doctor, you're adding 20% mass to the mission.
The idea here is that it's divided into 2 levels. You got laboratory.
In the 60s, during the Apollo program, money was no object in the race to beat the Russians to the moon. But now that the Cold War is over, funding a trip to Mars will clearly be a challenge.
We can't become a bunch of lazy engineers and mission designers and managements and say all the sloppy management and high-cost engineering we've done is okay because we'll just ask the public to pay more and they're enthusiastic about it. We have to go to the public with high value for their dollar.
You're going to Mars to live there.
The focus of this year's meeting is to design a program of 5 Mars missions costing a total of $32 billion. If the United States paid half and the international community paid the rest, that would come to $2 billion a year. As to why to go there in the first place, everybody in the Mars underground has strong reasons.
I'm a biologist, so I have this burning need to know about life in the universe. And the most likely planet in our solar system to contain either any present remnants of life or past remnants of life is Mars.
Did it have life in its past, when it had water, when it was like Earth? Could life survive their present, human life in particular? And could life be introduced to Mars in such a way that changed the planet into an Earth-like environment?
Mars is the new world. Mars is a planet which is waiting for human beings to go there, to explore it, to pioneer it, and to settle it. It's a place where a new branch of human civilization can be established.
Mars is a place that we can go and live, and that makes it completely different than any other planet in our solar system.
Many of the Mars underground leaders met each other as students here at the University of Colorado in Boulder. From time to time, they would gather at the campus observatory to share their dreams of exploring and colonizing other planets. Looking into the night sky, they often aimed their telescope at Mars, like one of America's most celebrated astronomers, Percival Lowell. Back in the 1890s, Lowell used his powerful telescope to capture some of the first detailed images of the red planet. Observing intense shifts in its climate and faint features that crisscrossed its surface, Lowell concluded that Mars was covered by an intricate network of canals, built by a desperate civilization trying to cope with alternating floods and droughts. Percival Lowell was not alone in his vision of a Martian civilization, but his work inspired an avalanche of science fiction about what Martians looked like and our first encounter with them. Tales of alien creatures captured the imagination of generations of children, many of whom went on to become part of the Mars underground.
When I was a boy, I used to read a lot of science fiction. They were certainly exciting stories of how people could go out there and create and build and adventure, and certainly the desire to be part of that adventure was a great thing for me and excited me to become a scientist. Now, in many respects, those stories were inaccurate. Sometimes the technical details were wild, and in almost all respects, their understanding of what Mars and the other planets were like were way off. But in a fundamental sense, I think they had more truth than falsehood, because what they showed is that these planets are worlds.
The origin of my interest in going to Mars actually came from a dream I had when I was a kid. I was about 8 years old, and I was on vacation at my grandparents' house, and for 5 or 6 nights running, I had this serial dream about going to Mars. And the dream started with, getting in the rocket ship and going to Mars, and then these various events happened, and as I recall, I was on Mars for about 2 years, and I met these different people, and in fact, I met my husband and got married and came back to Earth at the end of the dream. And I believed completely from that point forward that I was going to Mars.
American spacecraft rendezvoused with Mars 6 times between 1964 and 1976, Viking 1 and 2 actually landing on the surface. The payoff was spectacular. They sent back images of a planet that looked remarkably like our own. To see if there was life on Mars, each Viking lander scooped up a sample of soil. Of 4 chemical tests run on each sample, 3 were positive. But the results of the 4th and most important test were negative, leaving the question still unanswered. Photos taken from orbit showing strange parallel lines and a rock with the impression of a face rekindled speculation about a lost civilization. But it was images like this, what looks like frost on a summer morning, that intrigued scientists most. Ancient river channels signaled that Mars used to be warmer and had flowing water. And polar ice caps gave proof that water was still there.
They showed us the real Mars. They showed us a planet that was not like we had imagined, not with canals and civilizations, but they showed us things that were just as interesting. They showed us that at one time, Mars was a different world, a wet world, an active world, maybe a lifelike world. And that image, the notion that there was at one time 2 Earth-like planets in our solar system, has been the driving focus for Mars research ever since.
Mars Explorer 1, you're go for TMI.
After checking all systems on their spacecraft, the crew would take its last look at planet Earth as it prepared to leave the relative safety of Earth orbit.
Roger, go for trans-Mars injection. 30 seconds till burn.
In 10 minutes, they would burn all the fuel in their upper stage rocket and begin the long coasting ride to the Red Planet. This would be the last time Mission Control could directly oversee a critical maneuver.
10 seconds till burn.
Soon, the spacecraft would be out of the range of communication.
Engines armed.
5, 4, 3, 2, 1.
The end of the burn would signal the first momentous step for a 6-month journey to Mars.
Success to Mars.
Hey!
With the upper stage rocket and its fuel gone, the crew would have reached the point of no return.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
When Apollo 11 landed on the moon in 1969, going to Mars no longer seemed like science fiction, and the world was riveted.
I came back and listened to people who would come up to me and say, I want to tell you where I was when you were up there. Time after time after time, the lives of people on this planet were changed because they experienced something that had